Hi guys, if you have been following my channel, I've started a new series known as RAG Chatbot Production Level, and just a video has been published, Getting Started Chapter 1. But in this video, I'm going to show you a closed source solution with OpenAI Assistants. And now this is not the main goal of the entire series of videos that we'll have, but it's always better to benchmark with the closed source models, and then you would be able to know how you are performing, how your open source model is performing. So essentially, if I would like to summarize everything, we are building a RAG application, and especially we are trying to build a chatbot that can talk with your own data. So for example, we have this raw data sources that could be your PDFs, your text, any JSON files like SQL database or NoSQL database. So any such data that you have, those data are extracted first using OCR for PDF, for example, text file. You extract those data, and then you need to chunk those data because the LLM cannot take the entire document as a whole because it has fixed finite context window. So these chunks are made into embeddings. Embeddings are basically turning the chunks of different groups of words into numbers, and they are not just random numbers, but they are vectors, meaning they store the semantic meaning. So for example, when I say apple, it could be the apple fruit, or it could be the apple brand. Now depending on the sentences that you say, so I would like to eat an apple, that is a fruit. But when you say I think apple is better than Windows, then that's a brand. So you need to get that semantic meanings, and for that, converting it into the embeddings, and that to proper embeddings is very essential. So we need to have a very good embedding model. Now we'll discuss more in detail, but I'm just giving you the summary and basic highlights of what we're going to see in this series of videos. So stay tuned, and we'll come to know everything very soon. So embeddings are stored in a vector database. Now these vectors, the embedding vectors, are stored in that database because the vector database, we have so many types of databases. Vector database is one such database which stores the vectors that has been formed in the step, the embedding step. So what vector does database allows it is for two things. First is you can store the vectors there. Now it is not only essential that you can store that, but getting out the relevant pieces of information when asked so, or retrieve the best matching pieces of information, that is another quality that a good vector database should have. Meaning when the query from the user comes in, and that is embedded again with the same model here. So the query in the form of text comes in, that is embedded to vectors or numbers, and that embedding is passed through the vector database. Now once that embedding is passed to the vector database should be smart enough to return relevant data, relevant pieces of data. Let's say I want k equal to 5 similarity data, so it will return me 5 chunks of data, and using those 5 chunks of data, we are going to push that to the large language models. So we can use any large language model here. We'll pass in the query as well to the large language model, and we'll construct a prompt saying that given these pieces of information and given this query, construct a very good response for the user. So we have the query here, and we get the response here. So this is two separate parts of data flow. The first part, data preparation, that is the offline mode. You can just put it offline. Let's say you have a 1,000-page document, company document, and you can just store this, get the sources, extract the information, chunk it, embed it, and store it in the database. So that is an offline process. Now you host your app, and the user comes up, and the user says, hey, I want to know the details of my sales last month. So then that is converted to an embedding that is passed to the vector database. The vector database returns beautiful chunks. Those chunks are passed to the LLM, along with the query is passed also to the LLM, and then you get the response. Now you can integrate history, you can integrate other types of memory for your LLM, but that is again for the different video. Now in this video, I'm going to show you everything for a closed source model. So especially what we are going to do now is we are just going to give the sources of data and all these steps, the creation of embeddings, storing it in a vector database, and return of relevant information will all be done by the single model. Now in the OpenAI, we have something known as assistant. Now these assistants, I've made a little diagram for you as well. So we have this assistant at the center. Now this assistant, you can feed in different types of things, different types of tools. This assistant can use the file search tool, it can use the code interpreter tool, it can use the function calling tool. Now in this video, we're going to see the file search tool, which is related to the RAG application that you are trying to build. So assistant uses file search here, and then we have these files. We store those files in the vector database, vector stores. You just upload the files and that's done. And then you pass it to the assistant. Now, you know, this is pretty simple. We just need to have that assistant and we just start up threads. So threads are different messaging sequence. So if I go ahead and ask the assistant anything, so that will be a different thread. So all the messages will be stored in that thread because that will have the question asked by me and the response that it generates. So the next question, next response. So sort of the history and everything, all the interactions with the assistant from my side will be stored, let's say, in thread 1. Now when you come along and ask the assistant, from your system, you ask questions to the assistant, that will be made into a separate thread. So I think you got the idea, and this is, you know, pretty simple to set it up. So I would say if you just have 10 minutes and you need to present something, or you need to build a RAG application pretty quick, you can use this closed source. So we have assistant, we can create a thread, we add a message to the thread, and we run the assistant. So we're going to see in the code in just a second. But before that, if we go to the playground here, playground.openai.com, and in the playground, if you go to the assistant, you can see that you can select this assistant. You have these tools, file search, you can add files here. There is this code interpreter as well. You can describe different functions for function calling. You can also you want a response in a JSON format, you can use this. You can change the temperature, and that's it. So you can test this out here, but we're trying to do everything in the code. So let's get started on how to easily create this. Now file search, if you go to the read documents, I will attach all those links here. But file search, we create an assistant here, and then we enable the file search enable here. So we create an assistant, and then we just enable the file search tool. You don't even need to go through this code. I'm going to show you very easy. If you go to the playground, you go to the storage here, and in the storage you go to the vector store here. So in the vector store, I am going to create a new vector store. So create, and I am going to name it let's say prompt engineer. Okay, so press tick, and then I'm going to add files. Though I have a different folder for you, so I have downloaded 3 papers. That is, the first is the alpha LLM, and then we have the famous attention is all you need paper, and the last one is music generation, random papers from the archive. So I have these 3 papers. I want to insert these 3 papers, so I'm going to copy the link here, add files, and just click to upload. I'm just going to upload these 3 files here. So once I click upload, then all these steps of uploading and loading in the data. So all these steps of chunking it and creating embeddings and storing in a vector database, all these steps are handled by OpenAI itself. So you can just press attach. Now having done that, you can now start up an assistant. So you can just create an assistant here, and you can see this assistant, the ASST underscore, and you have this assistant. The last is NG. If you go to the assistant now, you can see that this is the assistant that we have just created. I'm just going to rename this, give it a user-friendly name, like say prompt engineer, and instruction. You can say you are a helpful bot. Reply. I can say your reply should be based on the uploaded files from the vector store. Let's see if this works. So we can just save this. Do you have any option to save this? Let's see. Or is it just fine? Yep, this is fine. So this assistant we're going to use in the code. This assistant has file search on. It has a few different files. We are going to use GPT-4 Turbo, and this should be it. We can increase the temperature here, and that is done. So we have this assistant now. Now we need to copy this assistant ID, because this is the important thing that we need. So assistant ID is this. Sorry, we need to copy this assistant ID somewhere. So this is assistant ID, and I am going to need an API key as well. So I go to API keys here. I create a new API key, and just click on create secret key. Just gonna copy this and paste it here for later reference. Now what I'm going to do is I've already created a code for you. So this is the folder. So we have 3 files here, but if you want to open this Visual Studio Code Editor from this system itself, you can go to the address bar and say cmd to open the command prompt, and then you can say code space dot. This will open the Visual Studio Code Editor with that files opened. So I'm just going to close this for now. And what I'm going to do is, first of all, this is the .env file. We are going to attach the OpenAI API key that we had here. We can just attach that. Okay, so we can just attach this and Control S. Now I have this app.py code, and I will just explain this to you. But before that, I need to create a virtual environment. So how to create a virtual environment? We say conda create -n. I'm going to create a new environment known as test Python 3.11.y. Now if you press this, virtual environment will be created in the name of test, but I've already created one. I can see the list of virtual environments by saying conda space info space --envs. So we have this environment test, and now I'm going to say conda activate and test. So this is going to load up the test here. Now I need 2 libraries. One is pip install OpenAI, and the other is python.env. So you need to install these 2 libraries as well to get this started. I've already installed. You can install on your own. So this file app.py, I'm just gonna minimize or maximize this, and now I'm just going to first of all paste this assistant ID. I'm going to paste this assistant ID in place of this assistant ID. So what I'm going to do is now briefly walk you through the code. So from OpenAI we import OpenAI, from OS we import the OS, from .env we import the load env, and we load the environment variables. This is for loading in the environment variables. So when I start up a client known as OpenAI API key is equal to os.getEnv, an OpenAI API key. So if you go to the environment, this is the OpenAI API key, and now we can extract this. So this is a beautiful way of keeping your .env file, secret key hidden from the main code. Now we have this assistant ID. Now, if you remember, when you say you have that assistant ID, when you say that you have an assistant, this means that this assistant is related to the vector store as well, because we can see this is the vector store, and this vector store, if you go to the storage, this vector store has 3 files which we have uploaded here. So there are 3 files. Attention is all you need, paper, alpha, LLM, and music generation. So all these steps of chunking and loading in the vector stores, everything has been done beforehand, and it's very easy to just ask question. So we are going to create a new thread. Okay, we are going to create a new thread every time, and whenever you start a new conversation. And so this is how we create a thread. So thread is equal to client.beta threads create, and then thread underscore ID is the thread.id here. So we get the thread ID here. Now I've defined a whole function here in the name of define chatter, and this will take it the user input. And once you have the user input, we add the user input to the thread. So client beta threads messages create, and we add, this is the thread ID, the role is the user, and the content is the user input that we hear. So we add the user input to the message in the thread itself. Next we run that thread. So we run is client beta thread run create and poll. So thread is thread ID, and assistant ID. So we now know the thread and we now know the assistant. So we run this thread. Next we list all the messages, and we take the messages from that particular thread. Now once you get the message, we want to get the latest message here, so therefore it is 0, and you get the content and the text here. Now that text has 2 things. First is the annotation, and then we have the value itself. So the message content dot value here is the reply from the bot, and these citations are the citations that has been referenced. That this could be blank if you ask some general questions, but if it is related to the vector store, then you will get outputs in the form of the file names here. So assistant is all you need. You can see those as a reference. We'll see it in the running, and then you will be able to appreciate that. So while true, we have user input is input, type a message here, and output and references are stored using this chatter user input, and then we're going to print the outputs and the reference. So we're going to run this. I'm going to say python app.py, and let's see. Let's open this papers. Now I wanted to ask this questions: diffusion transformers, what is DIT? Okay, so what is DIT? And ask this question. Since we have already stored this data, and it has been stored in the vector database, which is managed by the OpenAI itself, we should be able to get the answers and the reference as well. So you can see that DIT stands for diffusion transformers, blah blah blah, and we get the reference as 0 here. So 0 is the music generation.pdf. Pretty cool. We get the reference as well, since we are building a RAG system. Now this is boring. We need an UI to work with, so I've made another code which is the streamlit version. Now the major changes that we have done is we import streamlit as st. Now before that we need to install as well, so pip install streamlit. So we need to pip install the streamlit as well. Once you do that, we can now import streamlit as st. Then we're going to say st.title. So this is a title that we'll be seeing in the front page and the top of the main page. The function is the same, the chatter function, no changes here. Then we are going to take input we're gonna have display this, enter your messages, and then you're going to take the input from the user. Now we will have a button known as submit button. So if that button is pressed and if there is input, if you have put some inputs here, then you can just run this. So outputs and references will be stored after running the chatter input, and then you're going to st.write the outputs and write the references. Let's run this, and you can see streamlit run app streamlit.py. So this will run it in the localhost. So we have this beautiful streamlit app. So I'm going to run through this again. When we say st.title, prompt engineer's chatbot, this is the title here. When I wanted to take an input here, so enter your message, so this will be displayed here, enter your message. And when you say st.text input, so this is waiting for the text input. This is the submit button here. So when you click on submit, and if there is something written over here, then we can get an output. So what is it? And if you press submit, it's going to check if you have written anything here. If that is so, then it will proceed to run chatter and get the output and the reference. So let's see. So we have this output here and we have this reference here. Now that is pretty cool. You can see in just a few steps we were able to run this and set this up and get it started. So you can add any number of files, and this is very interesting with OpenAI, is that you can add any number of files here, and basically it's a very easy system to get started. But I know there are costs associated with it. You have $0.1 per GB per day usage, and also the usage of the AI or the inference that you're doing. You will need to bear cost, but if you want to get something running, test out your idea, this is something you can do. But I know you're not here for this. You are here for the open source solution, and which is something I will go ahead and build in the next series of videos. But this is something I wanted to share with you when you have the entire system which is ready-made by the Assistant API of OpenAI. Now, having said that, I think you got a pretty good understanding of the closed source RAG applications using OpenAI, and this would be good for testing out the ideas very soon. If you like this video, please subscribe to my channel, like this video, and share this video with others who want to check out the closed source OpenAI models. Now, if you want to support me, please support me at Patreon. Now, having said that, I think this is a long video, and please watch the next videos in the series. I hope you have a nice day. Thank you so much. Adios.